assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
All right, so here we're given a few reactions and asked to predict the products and then go back and balance. So the first reaction that we have is Be beryllium plus bromine, which is a diatomic element, and that's why you see the little 2 there, kind of as a subscript. All right. So we notice that beryllium is a metal and bromine is a nonmetal. So that means that they're going to be forming an ionic bond. Ionic bonds are made from ions, and so what we need to do is figure out the charge of each ion. That way we can balance it as a product. Okay? So the way this reaction is set up is you're taking 2 simple elements and we're combining them together into one balanced compound based on the charges. So when you're forming your product, we're going to kind of come to the bottom and write down the symbol for each of our elements, beryllium and bromine. Then what we'll do is we'll look at our periodic table. We'll locate those elements, which will then help us determine what the charge is. So beryllium is in the second column of the periodic table, which means it has a tendency to lose 2 electrons, so its charge will be +2. Bromine is in the next to last column of the periodic table. It's 1 electron away from the noble gases, so it has a tendency to gain 1 electron. Its charge will therefore be -1. So now what we need to do is put them together so that the charges balance. If I have 2 positives and 1 negative, that means I will need 2 of those negative charges to balance out with the positive. So I'll end up with 2 bromines paired with 1 beryllium. All right. Then my final step is to go back and balance my equation by changing the coefficients to make sure everything is balanced. So I have 1 beryllium on the left, 1 on the right, 2 bromines on the left, and 2 bromines on the right, so it looks like everything is balanced. Okay. So now what I'm actually going to do is I'm going to jump down and work reaction C for you, because it is also a synthesis reaction where we're taking the elements and combining them together. So here we have magnesium, this time being combined with oxygen. So same thing, we'll write down 1 of each element, magnesium and oxygen, then we'll try to locate their charges. Here, magnesium is also in the second row of the periodic table, so it will have, or second column rather, of the periodic table, so it will have a +2 charge. And then oxygen is actually in group 16 on the periodic table. It's 2 electrons away from being a noble gas, and so it tends to gain 2 electrons or have a -2 charge. These charges are already balanced out, so I'll just need 1 of each of my elements in the product, MgO. Now I'll go back and balance. I have 1 magnesium on the left and 1 on the right. I have 2 oxygens on the left, but only 1 on the right. So to balance those out, I'll add a coefficient of 2 in front of my product. That then unbalances magnesium, so I'll go back and add a 2 in front of magnesium as well to get everything to balance. And by balance, we mean that you have the same number of each atom on the left as you do on the right. Now finally, we'll hop back and work reaction B, which is strontium plus water. Now instead of being 2 simple elements that we combine together as synthesis, this reaction will actually take the form of single replacement. You have a single metal atom that will try to replace or swap places with the hydrogen in water. Now to make sure that this happens, you'll want to check what's called an activity series. Now what that means is that for this to work, strontium has to be more active or more reactive than hydrogen. So typically these reactivity series are found in the back of maybe a textbook or maybe on a reference sheet that your professor has given you. But it's kind of a vertical list of elements, and the higher up the element is, the more reactive it is. So what we want to check is we want to make sure that strontium is higher or more reactive than hydrogen. And if you look at an activity sheet, it is, which means those 2 elements can swap places. So strontium will trade places with the hydrogen, And what we'll produce are a metallic hydroxide and hydrogen gas. So the hydrogen gas, which is diatomic, so H2, comes out, and then it tells us, based on our kind of single replacement rules, that we'll be making a metallic hydroxide. Okay? So by metallic, that's just referring to our metal, strontium. Strontium is in the second group on the periodic table, and it will have a 2+ charge. By hydroxide, that's referring to the polyatomic ion OH-, all right? And that might be on a reference sheet somewhere as well for you. So again, we want to balance the charges. It takes 2 of the negative hydroxides to balance a strontium. Because that's a polyatomic ion, which means more than one atom, I'll put it in parentheses before adding that 2. Okay. Then I'm ready to go back and make sure that everything is balanced. So my strontiums are good. Next, I take a look at hydrogen. I've got 2 hydrogens on the left, but 4 on the right, or so it seems. So I need to go back and put a 2 in front of water. So that now gets me 4 hydrogens on each side, and that should take care of balancing my oxygens as well. 2 oxygens on the left, and then 2 oxygens on the right. So everything is good.